Okay, I'm seeing that we're slowing down um, with the people are slowing down joining. So Helen, if you want to get going, the floor is all yours.
Okay, great. Thank you. Well, yeah, good morning, everyone, and thanks for joining us today from a variety of different locations and time zones for the SZNet virtual workshop on subduction zone time series legacy data. We have an exciting program of 3 days of talks and discussions in store for you. So I'd like to take a moment to recognize the organizing committee for this workshop, Bern Schur, John Power, myself, Lorraine Huang, Melody French, Jerry Carter, and Carlos Cardona. Thanks to all of their efforts in putting together a great program. And also thanks to Juliet in organizing the logistics for the workshop and generally keeping us all on track for what will hopefully be a fruitful next couple of days. Over the next 3 days, we have two main goals. The first of these is to identify and curate a list of unarchived and inaccessible time series data that could be of benefit to the subduction zone geohazards community if they were openly available. To guide conversations around these, we want you to consider the following questions. What is the significance of the data sets? What are the major hurdles to archiving each data set? And what are the potential solution paths forward? The second goal is to disseminate information from major data centers on archiving policies and procedures to help guide an informed discussion about the aforementioned questions. And more broadly, the workshop is organized by SZNet, which is related to the SZ4D initiative. Thus, we are particularly hoping to catalyze discussions around data sets that are synergistic with the goals of these activities, as well as discuss how SZ4D may be able to provide support to broader community initiatives with regard to data set accessibility. I'm going to spend a few slides giving an overview of these initiatives so that everyone is on the same page as we get started. So what is SZNet? SZNet is funded through the NSF ExcelNet program, and it is the international component of SZ4D. And it's meant to aid in coordinating the international community studying subduction zone geohazards. There are currently 15 groups or networks across 5 continents that are a part of this program. And one of its primary objectives is to improve subduction observations in Chile, which is, of course, one of the world's most geologically active, but also accessible subduction zones. And that includes data accessibility for this subduction zone. More broadly, SZNet is centered around 3 missions to compare observations of subduction zones around the globe with a common data set and understanding, to cooperate to consistently instrument critical subduction zones that can provide key and transferable insights, and to develop and nurture an international and diverse cadre of early career scientists as equipped to make necessary breakthroughs in subduction zone science. And here's just a map showing all of the partners from SZNet. And again, you can see they're distributed quite diversely around the world. And then there's also some non-regional research networks mentioned down at the bottom left-hand corner of the map. And SZNet is part of SZ4D, and SZ4D is a community-driven initiative for a long-term interdisciplinary research program to accelerate process-based understanding of solid Earth geohazards needed to enable forecasting at subduction zones. It is a strong focus on comparative studies in subduction zones with Cascadia, Alaska, and Chile identified as the primary 3 focus sites. And there are a variety of community proposals that are either funded, pending, or in prep, as detailed on the timeline in the graph. But for the purposes of this workshop, this isn't too important. Perhaps the most important thing to keep in mind is that SZ4D is people. It brings together a diverse community of scientists from a wide range of disciplines and backgrounds to study volcanic eruptions, earthquakes, mass wasting, tsunamis, and their interactions. And over the next few days, I want to encourage everyone to think broadly about how SZ4D can help in supporting this community with regards to data archival and access that will facilitate future subduction zone science. Okay, so that's the big overview of what's driving some of this. And I want to get into a little bit more detail specifically of what we're going to cover over the next 3 days. We'll have 4 keynote talks split between the first 2 days from our archival organizations. As you can see, day 1 and day 2 listed there. And these will be followed by a series of short talks on different themes. Today's focus will be on digital but unarchived time series data from a variety of different settings. Tomorrow's short talks will focus on unarchived data from Chile. And day 3 will focus on physical time series data such as paper or tape records. We'll also have 3 discussion sessions split between days 2 and 3. The first of these 2 will focus on archiving challenges both for digital and physical records respectively. And then the last discussion session will be a conversation about steps forward, both broadly and within the SZ4D community. And we want to give you the discussion prompts for these discussion sections ahead of time so that you can start thinking about them as you're listening to the keynotes today and the short talks and thinking about whatever data set might have brought you to this workshop. And so I just wanted to highlight these. So for the archiving challenges for digital and physical records, we're going to be using the same set of prompts, just thinking about digital data and physical data. And the main questions we're going to focus around are, what are the criteria for identifying critical legacy data sets for SZ4D? What are the major challenges to archiving legacy data? Are there potential pathways to overcome these challenges, taking into account the presentations from the archival organizations that you'll hear? What is needed to address these challenges? And what are the challenges of making legacy data fair, meeting modern metadata standards? And then for our last session, we want to focus on potential solutions for community archival needs, and in particular, what could the SZ4D community do to help? Now, of course, SZ4D can't solve all the data problems, but some possible examples might include helping to ingest at least some existing data into EarthScope or creating a curated list of available data sets to host on a SZ4D website. And more broadly, SZ4D may be able to provide support for community initiatives to tackle archival challenges that may be larger in scope than what can fall into the previous categories. An additional possible direction would be to host a subsequent in-person workshop or other follow-up activities, and a discussion of what would be most beneficial to this community would be helpful. So that is what we have in store over the next few days. I think I took a little bit less than the full 15 minutes, but unless anyone has any questions or concerns, we can probably move on to our keynotes.
Thank you very much, Helen. Without further ado, why don't we move on to our keynotes? So we have Benoit Taisne and Jerry Carter. Benoit, if you would like to go first. Helen, I will let you introduce the speakers.
Yeah, sure. So our first speaker is going to be Benoit Taisne from WOVOdat, and he'll be talking about WOVOdat and GVMID Global Monitoring Volcano Database, challenges in populating, maintaining, promoting, and using. So please take it away whenever you're ready.
All right, thank you for the opportunity to present, and I should be able to share the slides.
Looks great.
Here we go. Hopefully we'll be all good here. All right. Well, thank you for the opportunity again to present the recent developments into WOVOdat and GVMID. I'd like to acknowledge the source of funding because yes, there is funding needed to maintain those databases, right? And I will have one slide following up the prompt from the team. So the current team is funded under the National Research Foundation. And past team that's really like a quick start, kickstarted the project, has been funded by the Earth Observatory of Singapore. So we have a change in the funding landscape. I'll be following the prompt given by the team, giving you a little bit of backgrounds, the type of data that we are looking at, the guideline that we have in place, the costs, and finally the challenges and what we offer to overcome those challenges. So if we look at this image on your right is an image that we took from the Merapi Museum in Yogyakarta, Indonesia. And we all have different version of this slide, right? We have different type of instruments sending data to an observatory, and the observatory is analyzing those data and pushing the information to aviations, local communities, to mitigate the impact of the eruption. There's a few key things here that I think leads nicely to the aim of WOVOdat, which is to archive unrest data, not the raw data, a derived product from raw data, leading that have been recorded at different volcano observatory, leading to eruptions. So we're looking at the unrest data. Worldwide. Why? Because then the aim is to be able to compare different unrest data from different volcanoes and have your own assessment of your ongoing crisis. The aim is also to provide unrestricted access to all those monitoring data, so people can use them for research, for real-time analysis of an ongoing crisis. And at the end of the day, support really hazard assessments and mitigates the impact of a volcanic eruption. And you'll see there's a lot of institutions that contributed to this project. It's really not one team, but a global efforts. So the rationale behind this data set is really the challenge when you want to compare data from different volcanoes. They might have different formats. The database structure might be different. So the end goal of WOVOdat is to address those by having a standardized way to store the data and for the user to query and access the data. The map that you can see here is a global map of the data that we have. In yellow, we have no data associated to those volcanoes. And in red are the volcanoes with data, with the caveat that those data could be any type of data, don't have to be a full-fledged monitoring data. It could be one or two types of instruments. And the instruments we consider, the seismic instrument at least, are within 30 kilometers of the volcano. And you have two references here that you are welcome to take a screenshot and scan later. The paper by Chris Newell and Fidel Costa that presents the structure and the rationale of WOVOdat. I keep talking about data, but there's no data if there's no instruments. And one of the secondary database that's derived from WOVOdat, I think it's a natural extension of WOVOdat, is the monitoring infrastructure. So in this database, GVMID, you will find the locations, the type of instruments, when they were installed, when they were dismantled, if they were. And for now, we have more than 100 volcanoes monitoring network. You can, again, take a screenshot and scan those QR code later. We have Christina that showed the structure of GVMID. And here we have a paper led by Tanya that makes use of the information. So we use in this paper seismic network, and we assess their ability to detect migration. So when we have this database completed, you can imagine the wealth of analysis that we can do, from optimizations, characterizations of a network, how to further enhance monitoring capability by adding 1 or 2 stations in key locations. All of that based on the mining of these data sets. So I mentioned the past team. So the project started really in 2009 with a pilot test between Japan, Italy, and Singapore. But that's really a follow-up on discussions that happened 24 years ago. So you can see that building a database is not an easy task. It will take time and grow with the challenge of making it sustainable on the long term. And I have a slide on that. There's a few key achievements depending on the partners, new partners, different workshops to train collaborators on the use of WOVOdat, how to populate and how to use the data. And recent advancement that I will highlight later is now the ability to use web service. So we have now an API attached to WOVOdat, and the user can use the preferred programming languages to crawl through the data and do their analysis. So this is not what we have under WOVOdat. This is what potentially we could have. So if you look at the GVP catalog between 1950 and 2 days ago, there is the potential to have close to 1,200 volcanoes associated to close to 3,000 eruptions. And if we have really access to all of that, you can imagine again the type of analysis that can be done with this big data type of analysis. The data that we actually have are again not continuous waveform, but derived processed data, ground deformation, seismicity, thermal, gas, name it. The main source are from the volcano observatories that will contribute the derived data that they have from monitoring instruments, from report, logbook, image, and so on and so forth. But also from open databases that can be found. So we have secondary informations that we derive from those data. Including the use of remote sensing databases. So then it's all in one location, and you can compare, download, and do your analysis with one stop. As of a couple of days ago, we have 13,000 monitoring stations that encompass 16,000 instruments with more than 550 volcanoes that are covered. The data workflow before you reach WOVOdat, which is on the top right of your screen, there's quite a few things that need to be done. At the observatory level, there's raw data that are being collected from the flank of the volcano. They have their own processing, ways to extract information, and those are stored in local databases. What we need to work on with the colleagues is how to translate this database into a format that will be compatible with WOVOdat. And when this data is into WOVOdat, then they will have the opportunity to further query their own data set, but also all the data sets that are available through WOVOdat and do their own analysis. We can also use published data, open catalog to process and save metadata and derived products that we hope to be to make them like standardized and easy to compare between different volcanoes. But as you can see, is really dependent on those upload, and we have different ways for you or people that you know or anyone to contribute. Either send the original data and we can work together on translating and finding the correct format for WOVOdat. You can also submit a spreadsheet, a CSV file that have the format that can be directly uploaded into WOVOdat, and this format is provided. You can also submit a small amount of data through online forms, or upload directly into the database if you have the correct formats. Once again, feel free to screenshot and scan the QR codes. All of those is obviously documented into the websites. Having a clear documentation is time-consuming, challenging, but obviously necessary. So that's something that colleagues that want to build database might want to consider, having a clear documentations with key examples, so people can easily follow and use the database. I think one of the key challenges that we can highlight is you want people to use those databases to contribute into hazard mitigation. The WOVOdat structure is volcano-based. So the first level is the volcano. Then we have a range of informations coming from different databases, so background informations. And then we have the ground-based and satellite airborne instruments that are divided into different categories: seismic, deformation, gas, hydrology, campaign measurements, thermal, and met station. And you can see a different type of data below it. I might come back to this later in one of the challenges, because we have always new instrumentations, new ways to look at the data. So this database cannot be set in stone, and anyone building database should allow for flexibility to evolve the database. Okay, one of the key informations that was asked is really the policy. And people that contribute data need to be identified, either as individual or an organization. The projects will accept two types of data. People can contribute data that can be downloaded straight away, or they can upload data that eventually can be visualized, but not download, and only be available after 2 years after the date of acquisition. There's one thing, there's also a caveat when you have a database like this with people uploaded data. There's an assumption that people that contribute data are the owners of the data. So WOVOdat, WOVO, and IFC, it's one of the challenge to assess the validity of such claims. So that's again something that colleagues building database want to consider. For people using the data, again, the data in WOVOdat are not WOVOdat data. They are data that from people that contribute. The goal is to make them accessible, freely accessible for different projects, crisis response, of course, but also school projects, research, and so on. Make sure that the owner of the data are always cited and acknowledged into your research. The data into WOVOdat are of course not to be used to forecast an ongoing eruption, except if you have the mandate to do it, obviously. But for that, we follow the IFC guideline, and there's no, this platform is not meant for anyone to be able to do forecast in real time. Okay, and that's why we have the 2 years delay. So the real-time data, unless specified by the owner, are not available. When you cite data from WOVOdat, you not only cite WOVOdat, but you really cite the owner of the data, and that's part of the metadata. You will know who owns the data. And you're not supposed to charge, download and charge the data. We understand that it's an available data set, and people might do risk modeling. And if there is money that is made after that, we really hope that they will sponsor future developments and maintenance of the database. So that's kind of a graphical view of what I said. The goal of this database, the global database, is to have a better forecasting of an eruption by comparing ongoing activity with all the possible past data. There's a few ways to interact with the database, which is something that you might want to think up front. Different ways to submit the data that are highlighted earlier, and when these data are uploaded, then people can visualize. whatever they want. And I'll show you two examples. And the user can visualize, download, and do their analysis. In terms of knowing the type of data and downloading the data, there's three different ways. You can search by volcano and see, so that's on your left, and see the type of data available. You can do a Boolean search where you want to look at, for example, like all the network events like hypocenters or the deformations, GPS or tilts. And then the search will list all the volcanoes that contain such type of data. And recently, we have a web service. So now we have an API where online you can look at different things, but then what is important is this link. This link can then be modified in a script in your own preferred programming language and check if the data exists and download. So we have a paper that is under review right now in Belvoc that will showcase this capability. It's already online, so you can have a look at the websites and give it a shot. Otherwise, the paper will be out soon. And in terms of visualizations, you can compare two volcanoes side by side. Here we have Aso volcano and Long Valley caldera on your left. In the center, we have Colima 1998 eruptions, time series of different type of data, earthquake, deformations, degassing, thermal, and you can also overlay all of them together. In terms of the GVMID infrastructure or data query, similarly, you can have a map per volcano. When you move around, you will have the pop-up with the information on this specific station. You can download the information per station or for the full network, which again is very useful if you want to assess the capability of a given network to detect deformations, seismicity, and so on and so forth. The next few slides, the next 3 slides or so, are really to answer some of the key questions that were asked. For WOVOdat, we have, as of now, which is an active, growing database. We have, in terms of person power, 2 research fellows and research associates that came with a yearly salary. We also have student assistant and intern that come from computer science sometimes, or even from earth science. It really depends on the type of project and outcome that we want. This is a very fruitful collaborations that you can have with students, assistant and intern. There is a yearly cost of the domain subscriptions for the database and a couple of hardwares that need to be changed. There's a lot of travel to be done in terms of training, in terms of helping to install, develop the database locally. This can only be done if you have an active funding to support that. And in terms of hardware, we had an initial cost of 100,000 Sing dollar, conversion is at the bottom here. So 75,000 US dollar for the initial server. And right now we are getting an upgrade of the storage capability, and that's another 75,000 USD. Challenges which will likely all be facing. The challenge is when you upload data, sometimes the metadata are not always available. They might be lost. They might be in the head of a handful of colleagues that have the knowledge of the type of instrumentations, when they were installed, and so on and so forth. And if you don't have the metadata, it's really hard to have meaningful comparison in the future. There is an increase of the amount of data that are saved, and just to mention one example would be the DAS technology that generates huge amount of data, and those data need to be stored, right? Even though that is not storing the raw data, we're storing more and more derived data in a standardized way. So we develop new ways to analyze the data and store those results, right? So we need more space. And there will be new techniques, there will be new instruments. So that's come back to what I mentioned earlier into building the flexibility in your database for evolving and being able to ingest those new data. One of the challenges is the data conversions and uploads. You will be facing different type of data, different type of formats, different infrastructure. So that's also something to take into account. In-kind contributions are very important. Right now, we have some funding that will last for another 4 years or so. But contributions to the database is obviously welcome. Strategies to overcome those. There is of course a willingness to make sure that the data that you provide are properly attached to you being an individual or an observatory. So there's different options within NTU, the university I'm based, so Nanyang Technical University in Singapore. We have the possibility to provide DOI, so there will be a unique identifier to your own data sets that will ensure proper attributions of the data. There's also the data reports from built-in volcanology. It's a very short couple of pages paper that describe monitoring data. There's no need for in-depth science, but there's also a way to rubber stamp the data sets with proper attributions of the team that was on the ground collecting those data. And with BullVolc, we have a standardized format that can then be directly uploaded into WOVOdat. An amazing source of person power is students. If you have well-defined projects, even with a month and a half, you can have students looking at raw data and generating a standardized product that can be uploaded into WOVOdat. So we have started that, and it's been very successful. The students gain hands-on experience on monitoring. They can compare with chronology of eruptions. So it's a very simple project for them, but the outcome is more data into WOVOdat. And of course the costs, the hardware maintenance. If you take a bulk figure of 10% of the initial costs, every 7-8 years, you have to basically fully replace your hardware or upgrade your hardware. And at the bare minimum, I think an IT person is key. So salary will depend on where you're based, but I think a one person dedicated to your database is key. And with all of that done, you have the potential to have a great impact on your community. I'll stop here. I'd like to thank again the organizer for this opportunity, all the people that collaborated, and institutes that collaborated to WOVOdat, and the current funding agency, the National Research Foundation from Singapore. Thank you for your time.
Hey, great. Thank you very much for that talk. So we're going to do both of our keynotes and then have longer time for questions and discussions at the end. But just a reminder for everyone, the chat and Q&A functions are open. So if you do have questions that you would like to start getting queued up, please feel free to use those functions. But so now we'll have our second keynote from archival organizations of today. That will be Jerry Carter from EarthScope, and he'll be talking about SZNet and EarthScope. Jerry, are you ready?
Yes, I am. Can't turn my video on just yet, but okay, there we go. And let me share my screen.
That's the presenter view. So if you could just swap displays.
Okay. How's that?
That looks great. Thanks. So take it away whenever you're ready.
Okay, so thank you, everybody. My name's Jerry Carter, and I work for EarthScope, and I am the coordinator of the data services group at EarthScope. Let me move right into it. There's a key message here that I want everybody to take away, and that is data-help@earthscope.org. Just about any answer that you need for submitting data, for getting data, or archival formats, whatever you need. If you send an email to this email address, then you will get help. And in fact, just about everything I'm going to talk about, you can get help through this website. So let me talk a little bit about what EarthScope is. I'm pretty sure that everybody knows what IRIS is. And can you see my my pointer?
Yeah, we can see your mouse.
Okay, good. Okay. So we had IRIS and we had UNAVCO, which were both formed in the 80s. And went along for many years. Around 2003, we jointly had a project called EarthScope, which was a huge project that moved both seismic and geodetic sensors across the nation of the United States and then up into Alaska. It went on for about 15 years. But in the meantime, IRIS was awarded the NSF's facility for the advancement of seismology and geophysics, and UNAVCO was awarded NSF's GAGE facility, which is the geodetic advancement of geoscience. And so we both independently were operating these facilities, and then NSF decided that the next facility was going to be a combination of these two and was going to be run by a single organization. And so IRIS and UNAVCO decided to merge at that point. So in early 2023, we merged to become EarthScope Consortium. So IRIS and UNAVCO no longer technically exist, even though you may find the IRIS and UNAVCO names sometimes in some of our strings. Those are slowly being changed. The SAGE and GAGE facilities run through 2025, and then the NSF will give an award for the NGF, or the National Geophysical Facility. We have applied for it, sent in a proposal to be the operator of that facility, but others have also sent in proposals, and so we're anxiously awaiting the results of that competition. In the meantime, EarthScope has three sort of technical divisions. One is an instrument group. They lend out instruments. They run some global seismic and geodetic networks. There's an engagement group, which does education and outreach to the community. And then there's the data services group, which collects data, which processes it, archives it, provides then those products and raw data to the community free of charge and openly. So that is our job. We do make it accessible and open to everybody. We do have, in some cases, in fact, I'll get onto this a little bit later, but there is a case where you can have data that is put in an embargoed time period where only the PIs can access the data. However, they eventually must become open, usually within 2 years. And of course, if they're published, they have to be open immediately. So let me talk about what our data center looks like. We have data that's coming in either in real time from data providers, and it could be seismic, it can be any kind of time series data. It can also and GNSS data that comes in. We can also receive data in batch, and in fact, these are two different, in very large batches or in very small batches. We come in, we translate it. If we can support the format, then we will put it into a cloud-friendly container. This is usually mini-seed for seismic data and other time series data. Rhinex or Binex for the GNSS data. We also take in image data in formats. But if we don't support the format, like in SegY, we don't translate that usually into a mini-seed archive. And so we can actually take the non-supported formats and put it directly into a product container, along with, if you go through this, we take the data, we process it, we come up with QC metrics through our Mustang for the seismic data and other products. So time series based on velocity, oops, sorry, that should not have happened. We go back, yeah. We get velocity data from the GNSS, position data and so forth, time series. So we have a data products which are available, as well as the data in their raw format that all of the community can provide. Now, we have sort of two ways. You can either download the data directly to your site, so that you can process the data at your home institution, but you could also have an account. We are operating in the Amazon web or Amazon cloud. And so you can also have an account in Amazon and get direct access both to the data and to the products, and have all of the resources that are available through Amazon, through the Amazon cloud, to do work on those data and products. So these are the kinds of data we have. We have data from 15,000, almost 16,000 seismic stations that we're sending continuous data. Not all of them are still sending that data, but we do have data that stretches back to the 1970s and 80s that are in digital form and that are available. We have almost 2,000 GNSS and GPS stations that are sending data in real time or in batch that we get. So these are continuous stations from both the GNSS and from the seismic. We have temporary seismic deployments, and these are deployments where a principal investigator may come in and get a bunch of instruments from us or from their own, say a bunch of nodes for a nodal experiment, lay them out, do their survey, collect their information, and then bring it back. So we have over 100,000 temporary seismic stations that have sent data. And these typically last for a week or two, but some have gone on for months at a time. We also have about 1,000 globally distributed campaigns for GNSS data, GPS. I'm just showing the Peru, Chile, some of the campaigns that were, actually, this is just one of the campaigns. There's much more data here than these. And each of these campaigns might have roughly maybe an average of about 50 geodetic stations, GNSS or GPS stations associated with them. And all of those data are available through our data services right now. SAR images, I'm just showing Peru, Chile, or mostly Chile. And so these are just, you can see in the diagram there, there's the tracks of the images that we have and that are available in SAR. Data products, as I mentioned, we have many different kinds of products that are derived. This is one particular product that actually takes that transportable array and shows how the waves are moving across the array through time after the event. And there are many other different kinds of products that we also provide. Earth models, we have an Earth model collaboration. There's 178 models. Some of them are reference models, and some of them are derived models from the data, which can be searched, and you can take slices through them. You can download the data, and you can use these models and they're all available. And they're also things that people can contribute. So these are models that are contributed by the community. So how do you send data to EarthScope? This is sort of similar to Benoit's diagram, where we're taking data from volcanoes, from seafloor instrumentation, from seismic arrays, from GNSS stations, from GPR eventually, from magnetotellurics, boreholes, seismometers, and strain. So we get all of this data, which comes into our data source. The types of data that we accept, I highlighted the seismic, the GNSS, and the imaging, because those are our largest repositories of data, but we also take strain, atmospheric data, infrasonic, magnetotelluric, hydrological, hydroacoustic, wave glider, tide gauge, OBS, MET data, LIDAR, topo, and bathymetric data goes through the Open Topography program. And of course, the Earth models, which I just described. And there's probably a bunch more that I couldn't fit onto the slide here. But there are some things that are currently not accepted, and I want to emphasize that this is current. As Benoit mentioned, fiber optic sensing data, DAS for the distributed acoustic sensing, or DTS, distributed temperature sensing, are currently so voluminous that we are not able to take it. So we are working on the formats and the storage components. We will probably do something like the downsampling that Benoit mentioned as well, so that we can store that kind of data. And we're seeking the community input on that right now, and working with our European colleagues on the formats, as well as there is a published version for the metadata for the DAS data that we're working on, and hopefully coming up with a standard for that the community can use, and that will be accepted internationally through the FDSN. We are not event bulletin experts. We leave that to the ISC, the USGS, and other organizations. So you cannot search bulletins and phase picks. However, in the NGF and should we get the next generation facility for the geophysical facility, then we will probably offer bulletins that are derived from research studies. We're finding that there's a lot of people who are using machine learning and AI to come up with some new kinds of bulletins, and huge bulletins. And so we may have capabilities like that. Our intent is not to to replace the ISC or the USGS. They have the definitive bulletins that go out to the community, especially for hazard warning and so forth, and the definitive bulletin at ISC. But to more or less offer research bulletins to the community that will be searchable. But that's something that's going to happen in the future. GNSS is also in a trend that is going for higher and higher data rates. Currently, we will not accept anything that's above 20 hertz. For you seismologists, 20 hertz doesn't sound like very much, but you have to realize that one sample is about 135 kilobytes. So it's far more data than it sounds like. And we currently do not accept that. However, we will be working to figure out how we might be able to do it in the future. So how's our data flow work? So I mentioned before the kinds of data that we had. I talked about the permanent deployments, where we have seismic stations, geodetic stations that are sending data either in real time through the cloud, or by internet or satellite communications to us directly. Some of those deployments send it in small batches, and we can get those and unpack those and use those. And then there are the temporary deployments where people go out, they gather a data that it could be terabytes of data, and they would then just bundle all that data together and send it to us. Primarily, we take data in the mini-seed and GNSS formats, RINEX, BINEX. And in the case of temporary deployments, right now we take data in PH5. Eventually, we'll accept data in TileDB, and of course the GNSS formats. So, what are the time series formats that we will accept? We prefer to get things in mini-seed and with for the data, and the station XML for the metadata. And this, when you send data in these formats, it takes full advantage of our search and retrieval tools. You can get down to, I said, I want this station, this channel from this time period, and we will get that data and send just those data to you. Same thing with the PH5 and TileDB for nodal data. The data, they are available through those search and retrieval tools. So the same kind of thing, you can take just a swath of data. You don't have to get all of the data or the whole file of data. You can just get parts of it, whatever you kind of cut out, and get time periods, and geographic periods, and so forth. But we note that, or I should note that the PH5 will be retired sometime after a TileDB replacement is available. Maybe not right away, but we will try to do it. And the reason that we're doing that is PH5 is an HDF5 format, which is not particularly cloud friendly. We store things and manipulate data in the cloud in TileDB, which is more cloud friendly, it's like ZAR if people use ZAR. And so we've chosen TileDB, and that's the way we're going. Record images and other time series data sets, like in SEG-Y, we store those as what we call assembled data sets, and it just becomes a file, and you have to search through and download the data sets manually. You can't send in a program that says, I want this data and that data, and you can't sub-select from those. You just take the whole data set. So obviously we would prefer to be able to take advantage of the search and retrieval tools by sending data in the formats that we do accept. However, we do accept, record images and other time series data sets, like in SEG-Y. They just go into an assembled data set. GNSS formats, RINEX 2, RINEX 3, RINEX 4, BINEX, Trimble. We can take all of those. In general, the GNSS community has there's many types of GNSS receivers, and we're able to handle all of those, and they can just go in. We store them in a TileDB, and we can then pull them out in any format that you like. Imaging formats, pretty much we take any commercial format. Much of it would go to OpenTopo, topography data, and so forth. There is a NASA-based HDF5 format for WinSAR data, and we can get to that as well. So what are the procedures for sending data, seismic data, to EarthScope? So first you have to have a network code. And you can go to that website there to request a network code if you don't already have one. We want you to sign a data providers agreement with us, and all that does is lay out what we're going to do and what your responsibilities are, and make sure that everybody knows that these data, when they are submitted to us, are going to be open, that anybody can have access to them. You have to send in the metadata to us for validation, and we make sure that the metadata is complete so that the data can be used and searched. And then the data can be sent to us either streaming in real time or sent in batch. Record scans, there are proposed FDSN standards. I think Tim Ahern will be talking about that a little bit later, and Lorraine. So we want those scans to come in with the standards and the metadata that goes with them, which will make them, they will go into assembled data set Excuse the dog in the background. Somebody must be at the door. And again, help is available through Data Help. So any questions that somebody might have in doing that. The data provider agreement that I mentioned before, there are the contributor obligations, which are to send the data and metadata in acceptable formats to maintain the best version of the data and metadata. Remember that it's your data, so you get, you want to make sure that you have the metadata correct. We just check that it is conformant, but it is up to the data provider to make sure that the metadata is correct. And we identify a point of contact so that we can be talk to you. Now, our obligations are to receive and secure the data, so we make sure that it isn't going to go away, that we have multiple copies of it so that we never lose it. We do process the data to create products like the quality control products through our Mustang system. We do the data quality control, and we notify the network operator, that point of contact, if we find issues with the data that might need to be addressed. We make sure that the data is exposed to the user so that it is open. And then we provide statistics on the data distribution back to the network operator so that they know how much data has gone on. And Benoit mentioned also that about DOIs. And so when you actually, when you signed up to get a network, we will, through the FDSN, it's an FDSN service, they will mint a DOI for you. And so those DOIs are available. And in fact, you can go to the FDSN web service and you can get, if you're going to publish data, say, you can go in and say, well, you can put the query that you used to get your data, and it will bring you a list of DOIs that were used from that query. And so that would be a list of DOIs that you can use in your publication. Okay, in the geodesy side, you send a request for support through this website here. As I said, we're still in UNAVCO. We haven't changed that yet. But you can see that here you just check the boxes. You know, you can do geodetic images, INSAR data, terrestrial laser scanning, campaign survey for GPS or GNSS, permanent station, GNS, GPS, and you then click that you're going to submit data or products to the Gauge archive, what kind of data it is, and then you will get that starts the process of being able to contribute data. And again, help is available through our data help portal. Costs. Okay. In our capacity as the Gauge and Sage facility operator, EarthScope accepts almost all data from NSF projects at no cost to the provider. And in fact, we pretty much take data from anybody who's willing to give it to us without any cost to the provider. However, we are getting into an area where DAS and so forth, we may have excessive data volumes coming in, tens of terabytes, and we even have some data sets where people have requested 100 terabytes of storage. And that may have a provider cost. We don't know what that's going to be. That's why the question mark on the $ over there is. We have to have permission from NSF and talk to NSF about what they would take for or deem acceptable for storing data in our archive that's very voluminous. There's also going to be probably an exclusive data use period where we have exclusive data use, for example, particularly for nodal data. It does not work for continuous data, but for nodal data where you go out and you do an experiment, generally the principal investigator wants some time to be able to work on that data. They went out in the field, they collected all the data that, they brought it in, they deliver it to us, and then somebody grabs all the data and scoops them. So they would really like some period of exclusive use where they can do their research on the data. If they publish, then they have to publish the data or make it openly available to everybody. However, they do have some period that they can use the data and process it, and that may have some costs. And again, we have to talk to NSF about that. But I don't think that there's any problem in the SZ4D world for that, or in the SZNet world for that. So I also want to talk now a little bit, just one more slide on the data portal, an SZNet data portal. As part of our contract, EarthScope will develop a very simple portal that, because there are so many different scientific disciplines and each has domain expertise, and we need the right people curating those data. So I told you a little bit about what EarthScope does. Our expertise is in INSAR, in seismic and GNS, GPS data. But petrology, open topography, the things that Benoit was talking about, volcano monitoring, gas information, they are not our expertise. And so we're going to just build a data portal that will list all of the portals that, or all of the repositories that hold data. And then, short descriptions, and then a link to those repositories so that people can go to them and find the information that they may need to be doing the SZNet research. And thank you very much. That's what I had. I guess we're ready for questions.
Great, thank you. Yes, so now we have quite a bit of time for any questions for both of the speakers. And in particular, we encourage questions about how, if there's legacy data sets that you're interested in, and if you've encountered any barriers, how to address them. So please use the Q&A or chat functions to submit questions. And while we're waiting, maybe I can just get started with one. Could maybe both of you talk a little bit about, so I think, Jerry, you mentioned that the EarthScope database has digital data back to the 70s and 80s. But both of you, like, kind of how far back do your data sets go? Are there types of data that don't meet modern data formats that become difficult to deal with? Have you dealt with that? Maybe some comments on that.
I could start. We do have some film chips that people have scanned, and as I said, these are part of our assembled data sets, and they go back before the 70s and 80s. And as I said, we pretty much just take the scans and we store them and just make them available. We don't digitize or try to digitize the actual wiggles, and these are seismic scans. In them, we just allow them to be provided to whoever wants to see them.
On the WOVOdat side, we concentrate on the post 1950s eruption, and data can come from published paper, written reports. So it's a bit of data mining to go back in time, but we concentrate on 1950s and onwards. Helen, you are muted. I don't know if you're asking us a question or not, but you are muted.
Oh, sorry. Thank you. Yeah, Juliet, are you there? I'm not.
Hi, yes, I'm here.
Okay, yeah, I'm not 100% sure if I have full access to everything. Are you?
I'm not seeing any questions in the chat or in the Q&A. If no one has questions right now, I do want to say that both of these talks will be uploaded to the SZ4D YouTube channel, so everyone will be able to rewatch them if they want, or send them along for other people to watch who are not able to join in the moment. And if you come up with a question later that you want to ask these panelists, feel free to contact us at contact@szd4d.org, and we'll be happy to pass along the questions. I'm going to put that email in the chat, contact@szd4d.org. And I want to thank everyone for joining. Oh, we do have a question from Tim Ahern. Jerry, do you know how often the WWSSN film chip scans are accessed?
No, I do not know how often they're accessed, Tim. You may know, man. Do you recall from before? Did you have any stats on that? Oh,
Tim says infrequently is
Yeah.
my recollection.
yeah. That's what I would expect. I haven't looked at it lately though, and we're in the process of transitioning everything over to the cloud. We'll have much better statistics once we get everything lined up on the cloud.
Benoit, I actually have a follow-up question. Since you mentioned the 1950s, is there a reason for that demarcation?
I guess you need to start somewhere. I don't know if there's an historical reason for the 1950s, honestly, because even the people in initial discussions were maybe that's the date of birth of a few people that discussed that in 2000 in Bali. I don't know the answer to that. But if there is older data, I mean, there's nothing that prevents a database to accept data that are older than that. And then when you search, you can look for as far back and see if there's data available. So I don't know the rationale behind that. And that would be in line with some of the modern instruments that were installed as well.
Looks like there's some more questions coming in the chat now. So first from Carlos Cardona, EarthScope has a protocol. Sorry, this is a question. Does EarthScope have a protocol to have a temporal restriction over real-time data, mainly for national agencies such as volcano observatories? And yeah, so that's to you, Jerry.
Yeah, I think you mean to have a temporal protocol for real-time data. No, once I'm not quite sure what you're asking here. If you send in data directly, it can be forwarded immediately to whoever wants it. In other words, we can recast it to whoever needs it. So volcano observatories or whoever.
I think, and Carlos, feel free to mention in the chat, I think perhaps the question is maybe if it's data that is being fed real time, is there ability for it to be restricted for a period of time before being made public?
Real-time data, NSF has a policy that any real-time data must be immediately made public, be made open. But it's something that we could probably talk about.
And then there's another question. Yeah, so just following on from that, Diana says a comment in the chat that exceptions can be made. But then from John Power, Jerry, could you discuss the procedures for archiving digital data where metadata is unknown or does not meet mini-seed standard?
So what happens there is that we sort of set the data aside. We collect the data and then we work on the metadata to try and get the main parts of the metadata established before we can feed it into our system. Without the enough metadata or proper metadata, then our search and retrieval tools won't work very well, and we have a high quality of data, so we want to make sure that the data that we're providing and the metadata are accurate. So we sort of set it aside and work on it is what happens.
It looks like there's one in the Q&A from Martin Reyes. Thanks, Jerry, for your talk. In the EarthScope database, is there survey associated to 2D or 3D seismic data?
Well, we have nodal data, so yeah, you could consider that 2D or 3D, and certainly we'll have the capability of doing that with the TileDB once we get that format set and are able to put data in there.
Yeah, Elaine, is it okay if I add something to Jerry's answer if there's a lack of metadata?
Sure.
I think John Paul was asking, so it is a challenge. Of course, you want the metadata if you have it, but it could be quite a neat research project. There is ways to analyze the data and try to retrieve the instrument response, for instance. So that could be an interesting research project. I'll concentrate on the frequency band that is, we know the response is flat. And then I'm sure there is like still derived data that can be useful to be stored in database such as WOVOdat. But that's a challenge. Metadata is a challenge, yes.
It looks like there's another question in the chat, also for Jerry and EarthScope. Could Jerry elaborate on the tide gauge data that's archived?
But tide gauge data that comes in can be put into the mini-seed format. And so, yes, we definitely can take tide gauge. If you look in the mini-seed format, which you can get online, I think you can get the book, then you'll see that tide gauge data is one of the formats or one of the data types that will fit into the format.
Okay. Not seeing any more questions in the chat or the Q&A.
If no one has any more questions, our series of short talks is scheduled to start in about 30 minutes, and we can take a break and everyone can have a chance to stretch their legs, get some coffee, and we can rejoin this same link in about 30 minutes. So I think it's scheduled for 17:30 UTC. That's 10:30 a.m. Pacific time. And again, everything that was just said here will be uploaded to the SZ4D YouTube channel probably by the end of the day. And if you have any questions that come up a little later, feel free to email us. Thank you again to Benoit and Jerry. We very, very much appreciate the time you took to give everyone all of this important information.
Thank you. Thank you for the opportunity.
Thank you all, and we'll see you all in about 30 minutes.
Thank you.
Thanks.